Okay, we're recording. So this is a recording of 2019 AP exam for response number 1. This is a calculator allowed, or actually calculator required question on the AP exam. And this is Friday, April 23rd. Anyway, fish enter a lake at a rate modeled by the following function, as you see there. Fish leave the lake at a rate given by that function. Both these are measured in fish per hour, and T is measured in hours since midnight, T equals 0, so since 12 a.m. So the first question is, how many fish enter the lake over the 5-hour period from midnight to 5 a.m.? Give your answer to the nearest whole number. Okay, so what you're going to want to do, because they're asking for a net change, how many fish did we enter the lake? They didn't say left; they're just saying entered. So let's be very careful about this, and give me 1 sec, because I need to pull up another thing here on my other device. So 2019 AP calculus. Yeah, so simply all you're doing is you're going to integrate from 0 to 5 of e of t, and of course put dt at the end. That's what you're doing. That's it. You get 1 point for actually writing that integral first. And actually I should be, not lazy. So that right there, boom, you get 1 point. Then you actually have to do this in the calculator because it's a little too hard to do by hand. You could try to do it by hand if you want, but I wouldn't recommend it. I mean, at least the expression for the integral, but then to evaluate, you still need a calculator. So what you do, I'm going to go to my calculator. Let's see here. Applications, Smart View. Nope, back. Okay, so I'm probably just going to start typing these in under y1 and y2, because you probably have to recall these equations over and over again. That's usually a good idea. So 20 plus 15, second, no, why am I doing second? Sine. Pi x divided by 15. So the calculator does the order of operation. We'll do pi times x and divide by 15. I think I got that typed in correctly. Okay. Next up, we'll do 4 plus 2 raised to the 0.1 x squared. Okay. I think I did that.
Isn't it pi x over 6?
You're right. Good call. Okay. That would be bad, right? Okay. I just blame just doing all the computer stuff. That's why I blame. Okay. So anyway, you're going to quit out to the home screen. Then do alpha window, option 4. And we're going from 0 to 5, right? Because we're going up to from midnight to 5 a.m. And then get alpha trace y1 dx. I get 153. And they wanted you round it to the nearest whole number. So I say 153. And you have to give the units also. So you have to say 153 fish into the lake from midnight to 5 a.m. So you get 1 point for the integral and 1 point for the actual answer. So it's worth 2 points. I'm going to show you the scoring guidelines in just a little bit, so you see how that looks. Okay. Now part B. What is the average number of fish that leave the lake per hour of the 5-hour period? Now, they want an average value, right? Remember, average value is 1 over b minus a, integral from a to b, of whatever function you're dealing with. In this case, we're doing leaving the lake, so it's L of t dt. Now, setting that up is also worth 1 point. Then you got to use a calculator to evaluate. Now, the beauty here is that I could second, if it's set, oh, long mouse, okay. If it's second, enter, it repeats my most previous entry. All I have to do is just simply go back here and switch to Y2. Alpha, trace, option 2. And of course, I still have to multiply by 1/5. So maybe I'll just kind of insert 0.2 times that. Because remember, you have to do 1 over b minus a, so that's 1/5 times the integral. And so I get 6.059. Now, they didn't tell you to round here, so what this means is you have to give at least 3 decimal places. Just so you know, if it says 6.06, you don't get the point for the answer, unfortunately. If it says 6.1, you still won't get the point for the answer. And you do need to at least, just be on the safe side, just say, on average, we get 6.059 fish from 12 a.m. to 5 a.m. Just be a little more explicit, a little more OCD with your answer. Just, give a little more details. That's, sometimes more is fine. So that's part B. And notice that it was just easy to have them already stored, so I can easily call them up. So that's just, kind of the strategy is to take that minute or two in the beginning of the problem, store your equations there, and then you can call them up quickly. Because we're going to have to do it again for part C and D. Now for part C, at what time from 0 to 8 is the greatest number of fish in the lake? So this is an EVT problem. Part C is extreme value. You want the greatest, you want the absolute maximum. So first of all, you have to state that EVT applies. You need to make that statement. So, and I'm going to show you the answer key in just a little. And by the way, all the answer keys I am going to post to Schoology later. I was actually going to do it this morning. I got a chance of doing that. A little sidetrack, but if I don't do this afternoon, hopefully this evening I'll try to get that done. So it's an EVT problem, and how do I know EVT applies? Well, the things that if you're given the rates, then you know this is differentiable, right? If your differentiable is continuous, so we kind of assume that. And you have to test endpoints, so we are going to have to test 0 and 8, and we'll call this n, the number of fish in the lake, and we'll have to test 0 and 8. And what does n of t represent? N of t is simply going to be the integral from 0 to x of e of t, and then it gives an initial number of lake, right? Sorry, initial number of fish. I don't think we were told that. No. Okay. So we'll assume that we don't have any fish right now. So, and I'm pretty sure I have that set up correctly. Yep, I have set up correctly. Yep. I'm calling n the number of fish. They use a of t in the problem, and actually, I should call it x, but it's okay. So anyway, well, remember fundamental theorem of calculus as well. So you also want to test your critical points too. So n prime of t, I want n prime of t equals 0. That's a critical point. Well, if I take the derivative of this integral, that just becomes e of t minus L of t. And I want that to equal 0. So I want e of t minus L of t also equals 0 because the number of fish is the integral of the difference in those rates. That's going to be the number of fish, but then if I want to find extreme values, I have to test endpoints and critical points. I take the derivative n, and because n equals an integral, the derivative and integral, they cancel out. So n prime of t is e of t minus L of t, and I want that to be 0. Now, I actually could see where those are going to be. So essentially, you want e of t to equal L of t. If you were to do a little algebra here, You want E of t to equal L of t. So you want to see where these intersect. Well, fortunately, I already have them stored here. And we're going from 0 to 8, so I'll change my window from 0 to 8. I think my y values are fine. And make sure you're in radian mode, the graph. Okay, I can't see it, so I'm going to have to expand this. Expand this to maybe 40, perhaps. Okay, that I need to find. Second trace, option 5. Just get close to it. Hit enter 3 times. So 6.20356. So now what I have to do is I have to plug in this into. So now this is kind of the part that's you're going to have to be a little patient. So I have that stored. So I'm going to go and actually store that so I don't lose track of it. So X store. I'll call this alpha A. So it's stored because you need to be very precise here. Now what I'm going to do is now I have to find which of these provides the highest number of fish. And that's 6.204. 6.204. So which one is the highest number of fish? So I have to plug these in for X every time. And technically, I should actually call this X and N of X, just so you know. My notation is just a tad off, but whatever. So I have to integrate from 0 to X of E of t minus L of t. So let me go ahead and clear the calculator here. Now, first of all, the integral from 0 to 0 is 0. So that's easy. I don't have to worry about that at all. Now, for 8, what I'm going to do is I'm going to hit alpha window, option 4, 0 to 8, and I'm doing alpha trace y1 minus alpha trace y2. So, and plus you can watch this recording again because I know I'm doing a lot of stuff here. But again, so that's the beauty of kind of having a source. So I get 80.919998. So I'll put that over here. Nine one 9998. I mean, three decimal places are fine. And then for the next one, I just repeat it, second, enter, and change this upper limit to alpha A. That way we get a precise answer. So 135.014. So the greatest number of fish happens at 6.204 hours. So that's that's the time that would get us at. And we justified it by using the EBT. So that's a totally FTC at its finest, as well as integrals net change. So that was part C. So any questions before I move on to part D, and then have you guys try one on your own? Yeah, okay. Just 2018, number 1, this can be similar to this. It's a little easier. 2019 was actually, I think, a harder test. So I'm doing the harder one with you guys. But they do make adjustments to the scoring when they know the test is hard in previous years. Okay, lastly for part D. Is the rate of change in number of fish in the lake increasing or decreasing at 5 a.m.? Explain your reasoning. Well, the rate of change in the number of fish, is that increasing? So is the rate changing? Sorry, is the rate of change changing? So in essence, kind of like they want a second derivative. That's kind of what they're really asking you. So first off, the rate of change of fish is simply going to be E of t minus LT. Remember, E of t is the rate entering, LT is the rate leaving. So the rate of change in general is simply E of t minus L of t. Now, they're asking if that rate is increasing or decreasing. So you got to take the derivative of that rate. So it's going to be E prime. And we're doing this at 5. E prime 5 minus L prime 5. So that's what they want. So you have to be able to interpret what they want correctly. Which, if you think about it, this would be the derivative of the number of fish. But again, you have E and L functions. They want how the rate of change is changing, so you do the derivative of that rate of change. And just plug it in. So alpha window, we're doing derivatives, so option 3, x alpha trace y1 at x equals 5. And let me subtract that with the next one, alpha window, option 3, x alpha trace 2, x equals 5. So I get negative 10.772. That, of course, is negative. So what this tells me is that the rate of number change of fish is decreasing. And you can just make that statement is that because, E prime 5 S L prime 5 is negative, it's the rate of change of fish is decreasing at t equals 5. Now let me show you the scoring for this. So you know how to score it, and then I'm going to have you try one on your own. So here we go. So you see, they gave you 1 point for writing the integral for part A and 1 point for the answer. For part B, 1 point for the integral, 1 point for writing the answer. If you somehow botch the integral and get the wrong answer, you get nothing. So be very careful. For C, 1 point for realizing E of t minus LTS equals 0. That's because when I did the integral to represent the number of fish, that took a derivative and realized the critical point. So you had to find the critical point, get the answer, and then the justification is kind of like stating the EBT that you're looking for an extreme value. I think that's part of your justification. And then here's what 2 points for part D, concerning E prime 5, L prime 5, and of course getting the answer. And just explain A because it's negative, the rate of change of fish is decreasing. Okay. So again, that is how we would approach a question like that, integrals net change. Now, I didn't give you guys terribly much time to do a practice problem, but maybe you could try part A or part B perhaps, and just get the practice of punching the calculator, because at 12:35, we'll need to swap groups, and I need to do this with the other group, and then you guys will do an FTC problem with Sydney. So now let me pull up 2018. So past AP Calculus AP exams. Here we go. Very similar situation. So you guys should have this. So you're going 2018 number 1, salmon. So you have a function of people enter an escalator at a rate modeled by the following function. So where t represents seconds. So for the first 300 seconds, people enter an escalator at that rate. Then by that time, no one enters the escalator. The rate of people entering is 0. As people get on the escalator, they exit at a constant rate 0.7. So that's the exit. So you could call it like E of t if you want. Exiting is 0.7. And initially you start at 20. Initially got 20 people in the escalator. So the first question is how many people enter the line for the escalator during a time interval? So as you can imagine, you're just going to be integrating R of t, the really wacky part of it, from 0 to 300. So you're going to do that interval first. And then part B is during that time interval, there are always people in line for the escalator. How many people are in line at t equals 300? So you're going to have to do the R of t function minus 0.7 t because it's a constant rate of 0.7. And then, of course, adding 20 at the end because initially I had 20 people. That would be part B. C is going to be a little weird, but at least let's try A and B. See if you guys get that. I'm going to pull up the answers. And it may have fed you false information. For part B, your rate is just 0.7. So you're doing R of t minus 0.7 for the net change. If anyone has an answer to share, let me know. Okay. Let me show you the answer key really fast. Oops, I went to 2018. Yeah, so you're integrating R of t from 0 to 300 and just use your calculator for that. You should get about 270 people. And then for B, you start with 20, and you're integrating the net change. Remember, RT is what comes on, 0.7 is what comes off, that rate. So you integrate that from 0 to 300, and you should get 80 people. 1 point for the integral, 1 point for the answer for part A, 1 point for considering 0.7, the rate out, 1 point for the answer. And then for C, because no one else has come on, that's go after 300 seconds. And you know you have 80 people after 300 seconds, so you kind of need to know the answer part B to do part C. Then you need to figure out how long it's going to take for those 8 people to leave. So if the rate's 0.7 people per second, you do 8 divided by 0.7, see how long it takes for those people to leave. Or 0.7 equals 80 times x, you want to do that. Sorry, 80 equals 0.7 times x, and solve for x. And add the 300s to figure out how long it takes for the S to have no people on there. And then it looks like part D is an EVT problem. With that one more time. Yeah, you want it to be at a minimum. So you can see 2018 and 2019 number one were pretty darn close. They're pretty similar. And given that last year we had the pandemic, they didn't have the traditional AP. My guess is they're probably going to ask something like this again, which is why I'm spending time going over this. So, all right, let's close the breakout rooms, have everyone else come back. So you got a little taste of that kind of problem. And by the way, there's other problems in 2017, 2016, 2015 you could try as well. I'll stop my recording.